All right, guys. Dr. Darbro, this is kind of where hypothesis testing meets confidence intervals. And it's a common procedure sometimes to make a statement or decision on your hypothesis, on your null hypothesis, using a confidence interval. There are times it works, and there are times it doesn't work. And I want to point out when this happens. Now, let's think about what happens with a confidence interval. For example, if we are testing mu equals some value, and let's just call it mu 0, versus mu greater than mu 0, whatever this value may be, and let's say we're testing at 0.05. In our distribution of sample means, we are going to put all 5% of our rejection region in the right-hand tail. Okay? Now I want to draw this a little bit larger. So we're putting 5% of our rejection region. So guys, what we have right here is we've split our distribution of sample means into two parts. Into the reject region and the fail to reject region. Now I want you to think about what happens if we have a confidence interval. Whoa, that's kind of crazy. All right. Now, if we have a confidence interval, what we're looking for, well, it'd probably be nice if you guys could see that, right? We're looking for the value that separates out the middle 95% of our distribution. So in other words, we have 2.5% of our distribution to the left, and we have 2.5% of our distribution to the right. Kind of makes sense? Now, if we're using confidence intervals to make a conclusion about the null hypothesis, if mu is contained in our interval, then it should make sense to you that we're going to fail to reject. If mu is outside of our interval, then we're going to reject. But guys, if we come in here and look at, nah, it's not going to let me move it, is it? If we come in here and look at this part of the drawing, let's get some blue here. We've got a portion right in here that drives beginning statistics students absolutely crazy. Because if we get a mean in here, for example, what are we going to get? Well, we've got something that's contained in our interval, because our interval goes from there to there, but we've got something in our rejection region from the test of hypothesis. Well, guys, that's a big, gigantic contradiction. And just to illustrate this for you, I've come up with the following example. Okay? So let's say, for example, that we are testing H sub O, mu is 100. And we're going to test at alpha equal 0.05. So we go out and get a sample. Our sample mean is 102.83. Our standard deviation is 10. And our sample size is 45. Okay? Got it? All right, boys and girls, let's go to our calculator and conduct a t-test. So we go to Stat, go over to Test, go to number 2. We've got Stats, not Data, and fill in the information. So we got testing 100 from a mean of 102.83 with a sample standard deviation of 10 and a sample size of 45. Our alternative hypothesis is set correctly, so we go calculate, and you can see we get a p-value of 0.032, which leads us to reject the null. So I'm going to write that down over here. All right. So let's go back over to what I'm writing on. So we have a p-value of 0.032, so we reject the null. So our test is pretty conclusive here. There is evidence that we should reject the claim that the mean is equal to 100. And we find from our test of hypothesis that the mean is greater than 100. Well, if this was something other than an academic exercise, mean greater than 100 takes on a lot of values. And I would like to kind of collapse this and say, well, greater than 100, but give me more information. Where is it above 100? In other words, estimate mu. All we know now is greater than 100. So if we come down to number 8, we're going to get to a t-interval. And again, what's the purpose of a confidence interval? To estimate the unknown value. Now we got a little bit more information here because we think from our sample that it's greater than 100. Nevertheless, I'd like more information and interval with a specified probability of 0.95 where mu lies. And I run my confidence interval and I get a major issue here. And the major issue is a contradiction in that my confidence interval contains the value of 100 that I rejected with my t-test. So guys, that's a major contradiction because you want consistency in your test and your hypothesis test and your confidence interval. And we don't have that here. Now, let's go back to the blackboard and go back, let me see, go back to our drawing. Well, what happened in this situation is our mean of 102 I think it was 83, I forget exactly. Yeah, 102.83 fell right here. When we looked at our significance level in terms of hypothesis testing, it fell in the rejection region. But when I looked at the bounds of my confidence interval, it falls in that confidence interval. So, important note. H sub A must be not equal. If you're testing a claim based on a confidence interval. It's the only time that this will work. And if you think about it, why is it? Well, guys, if we're testing alpha 0.05 from an alternative hypothesis of not equal to, we're going to put half of our rejection region in the right tail, and we're going to put half of our rejection region in the left tail, leaving perfectly the bounds for a 95% confidence interval in the middle. So this negative t critical and this positive t critical will be consistent for my confidence interval and the test of hypothesis at a not equal to. So guys, here's the deal. Example. We are testing okay? So the criterion for using a confidence interval to test a claim is set up. Why? One simple fact. We have a not equal to in the alternative hypothesis. So what should we conclude from the following? Okay, gave you three situations here. A, what if our confidence interval ran from, for example, 22.5 to 24.25? And I can't take that right there. That's driving me crazy. Well, notice that the entire interval is below 25. So we would reject A sub O, and we would conclude the mean is less than 25 because the entire interval is below 25. Part B, notice our entire interval is above 25. Decision, reject H sub O. Second conclusion, statistically we conclude that the mean is greater than 25. Part C, conclusion, notice 25 is contained in our interval. So guys, when we have this, we failed to reject. And what do we conclude in the end? We can't reject the fact that the mu is equal to 25. Probably isn't 25. More than likely it's not. But statistically speaking, we cannot reject the claim that the mean is 25. So guys, what we've done here is I've presented to you a much more, I guess maybe straightforward approach. Not using critical values, not using p-values, not using test statistics, but just using confidence intervals to test hypotheses. All right, gang, that's it.